Hey, what's up? It's Jake, and we're getting to the end of the conditions and loops uh, module, section 3 of this thing that I'm doing, this review. And so I kind of wanted to put this together in the context of what we're doing. So this isn't going to be the most efficient way to do this, but it is going to use the concepts that we've been talking about. So you can create a prime number generator. So that is the first thing that we're going to do. And we'll go ahead and rename this so that, okay, prime number generator. Alrighty, so let's call this something, a prime number generator. And just think for a second, like how you would approach this. How do you create a list of prime numbers? So first, let's talk about what a prime number is. So a prime number is a natural number greater than 1 that is not a product of two similar natural numbers. Okay, so um, that's what we're looking for. The natural number greater than 1 that is not a prime is a composite number. So everything else is a composite number. So based on this definition, we consider the first, let's talk about the first 10 natural numbers. Okay. Um, And you probably know that 2, 3, 5, and 7 would be your prime numbers, while 1, 4, 6, 8, and 9 are your composite numbers. Um, well, and 10. In order to have a computer tell you whether a number is prime, and we'll call number n, you can divide that number by the natural numbers in the range 2 through n. So any of those divisions yield 0 as a remainder. Then the number is not a prime number. Okay, so we're going to write two versions of this. The the second one will use some for else syntax. So let's start with primes equal an empty list. So that's going to be our primes. And then we're going to make a value up to equals 100. Okay, so this is a inclusive limit. And then this is just going to be, this will contain the prime numbers at the end. Okay, so that's what I made so far. So we're going to say for n in range, and then our range is going to be 2, and then up to plus 1. Because remember, the range is not going to be inclusive. It will not include 100. So up to plus 1. And we know that it has to be greater than 1, so our starting value is going to be 2, and then our stopping value is going to be 100 plus 1, so 101. So it will do 100, but it will not do 101. So we're going to say is prime equals true, okay, which is, if you remember, what is this? It's a flag. So this will be new at each iteration of um, the outer for loop that we have on line 6. All right, so is prime is true, and then we'll say for divisor in range, and then we'll just say 2, and then whatever n is, because we have to go through each number, right? 2 and n. So I have a for loop inside of a for loop, and then I'm going to use a conditional. If n modulo n modulo divisor is exactly equal to 0, then is prime is going to equal false. And then we'll break. Okay, we'll break out of this for loop, and we'll go back into this for loop, and we'll say is, and then we'll set the if is prime, then we'll just say primes for our list dot append whatever the value of n is. And then at the very end, we will just print the primes list. Okay, hopefully that makes sense. All this is right here, by the way, is just a check on our flag. Okay, so let's go ahead and run Python prime generator. and we go, whoa, what is this? So 2, 3, 5, 7, 11, 13, 17, 19. So this looks pretty good. It's all the prime numbers up to 100. Okay. There are a lot of things to notice in this code. I set up the empty primes list, which will contain the primes at the end. Limits 100. It's inclusive. Calling the range in this outer for loop here. This is my outer loop. This is my inner loop. So yeah, so if you have any questions, let me know how I'm doing that. But I will pose this to you. So of all the iterations in the outer loop, one of them is different from all the others. Do you know which one that is and why? And if you think about it for a second, you go back to the code, try to figure it out, and then keep reading. So what might that be? If you don't know, that's okay. Pause the video if you don't want me to give it away. But I'll go ahead and tell you. So I asked you to do a small exercise to look at what something that programmers do all the time. It's a skill in understanding what the code does simply by looking at, and it's something that you will build over time. It's important, so try this exercise whenever you can. You can go to GitHub and look at code and see just like, what does this code do? And just read through it and see if you can kind of wrap your mind around it. So the iteration that behaves differently from all the others is actually the first one. The reason is in the first iteration, n is 2, right? So therefore the innermost for loop won't even run because it's a for loop that iterates over a range to 2. And it's actually just itself, right? So if you try this with a simple for loop, and your range, right, was something like 2, 2, like this. If that's your range, it's starting at 2, stopping at 2, but this is an upper limit, so it's not actually going to run this. So since it starts and stops on the same value, it's actually not going to run anything. It won't run at all. So this never actually runs on the number 2, but it does print the number 2, which is interesting, right? So from an algorithmic point of view, this code is inefficient. So we'll do a more efficient version here. And just to make this a little bit more reusable, I'm going to define bad primes. And then I'm just going to take all of this and I'm going to stick it, and that's now a function. And now I'm just not going to call it. So if I do this, it doesn't do anything. If I called here, if I said bad primes and I called it, then it would actually run. So in the case where I have two versions of something, if I create one of them as a function and I don't call it, that code it's wasting memory, but it's at least that I can write two versions of it. So I'm going to write one called good primes. Okay. All right. So in here, what I'm going to say is for n in range, and then my range will be 2 and then up to plus 1. What do we want to do? Well, for divisor in range 2 comma n, then I want to go if n modulo divisor equals divisor is equal to 0, then just break. And if break. And after my if statement, in the inner loop, I can say else, which gets rid of my flag, right? Primes dot append n here. And then now I can just print primes, right? And then now to test this, I can call good primes and see what this looks like. And we get the same exact result. So this is a lot cleaner. This is a more Pythonic, more efficient version of this code. The primes flag is gone. I use the special else clause, which is something I did in a previous video. And we still get the primes list, and we know for the inner loop hasn't encountered any break statements. So yeah, so that's a much better version of doing that. So that is a prime number generator, and you can make this script and add it to your list of scripts. And I encourage you to keep all these scripts for yourself so you have both examples for yourself for future reference if you need to write some code, and also just to, put in like a GitHub repo to be like, here's some stuff that I built. And as you get better, you might be embarrassed of some of these things to be like, that's it. You did a print statement and you did a binary number generator or a prime number generator or whatever. And it'll start out with simple stuff like that, and that's fine. And then when you get better and your code becomes more complex, as you start growing, then it will become more impressive and things that you can actually use to like get jobs and stuff. So, anyways, if you have any questions, let me know. And if not, then I'm going to go into a more complex discount application.